Hi everybody, thanks for watching this video. This is about cyclic quadrilaterals. You may not know what those things are yet, but hopefully you will when you're done watching this little video. So look at that quadrilateral inside the circle there, a nice shade of pink. Doesn't look like there's anything very special about that quadrilateral, does it? It doesn't look like a kite or a rectangle or a trapezoid. I could move it around and I could kind of, make it, and that looks sort of like maybe a trapezoid or a rectangle. I don't know, it's hard to tell. I could probably come up with a kite. That looks sort of kite-like, kite-ish, inside the circle there. So there's like a special rectangle that you are familiar with. It's there. Other than that, there's nothing really special about these. They look like just kind of random quadrilaterals, all right? But I would like to let you know that this is not a random quadrilateral. There is something very special. And what I thought I might do to just kind of demonstrate that is to try and just draw a random quadrilateral and see if I can put it inside a circle. So I'm just going to draw a quadrilateral, nothing really special about it. Okay, I just picked 4 points. They made a quadrilateral. I'm going to draw a circle now and see if I can get that circle to fit over all 4 of the vertices of this rectangle. So it looks like I'm going to have to make it bigger. Okay, so I'll make it bigger and see if I can get it to fit. Okay, so we're getting close there. It looks like I can get 3. That looks pretty good right there. It looks like I got the circle going through 3 vertices of that quadrant, but I'm not going to make it through the 4th one. If I move it around, there's just no way. There's just no way that one circle is going to go through all 4 of those points. So it doesn't look any less kind of random than the pink one, does it? To me, it looks pretty much the same. But it does not have the feature of being able to be put inside a circle. So let's take a look again at our quadrilateral that is in a circle. Excuse me, let me get the circle. There we go. And so what makes this one special, all right? Well, this is called a cyclic quadrilateral, all right? This is a nice shape. And it has a very important kind of feature that you don't really see. It's really nice. First off, a cyclic quadrilateral is a quadrilateral. Here, let me get to this little graphic thing over here. Make it a little larger. There you go. Nice. A cyclic quadrilateral is a quadrilateral that has all 4 vertices on a circle. All right? And we could say that same exact thing in a couple of different ways. I could say that a cyclic quadrilateral is inscribed in a circle. All right? So you're seeing the word inscribed shown there. It means drawn inside something else. But you could also say that a cyclic quadrilateral is circumscribed by a circle. That is, it's a quadrilateral that has a circle drawn around it, circumscribed by a circle. Okay? All 3 of those things mean exactly the same thing. So I think you get what a cyclic quadrilateral is, but what's kind of special about it, okay? Let me move this out of the way here, is that there's a certain thing that's true about this quadrilateral that is not true about many other quadrilaterals. Some it is true of. For example, I could take this and I bet I could probably make this quadrilateral here very much like a rectangle. That's pretty darn close, I would say, to a rectangle. And you know some things about a rectangle. A rectangle is a cyclic quadrilateral, as it turns out. Okay? And there's other ones, like I think I had a kite up here before. This is like a kite, all right? You can draw a kite that is a cyclic quadrilateral. Not all kites would be a cyclic quadrilateral. If I moved one of those points around so that it was still a kite but no longer on the circle, then that kite would no longer be a cyclic quadrilateral. But this one is. Okay? So some kites are cyclic quadrilaterals. Rectangles are cyclic quadrilaterals. And there's something special about all of these quadrilaterals that I'm drawing inside the circle that you don't just see by looking at it. And that is a really special thing. So let's check something out. And it relates exactly to what we've been dealing with in class. All right? So I'm going to draw some stuff here. Now, follow my logic here. You know that the angle, for example, there at J, is an inscribed angle, and it subtends this arc all the way around from point G to point I. You know that. And if I take a different angle, let's say the angle over here at point H, that is an inscribed angle that subtends the arc from G all the way around to point I on the other side of the circle. Now just ask yourself, I know you know the answer to this question, but what do you get if you add those two arcs together? Yeah, they make the whole circle, right? So the sum of those two arcs has to be 360 degrees. Okay, well, you also know that an inscribed angle is 1/2 the measure of its subtended arc. So the red arc that I've drawn there at point H is 1/2 the measure of the big red arc that goes around the circle. And that black angle there at point J is 1/2 the measure of that black arc that I drew around the circle. So the sum of the arcs equals 360, and the angles are each 1/2 of the arc. So what is the sum of the angles? Yeah, it's 180. And that's what makes a cyclic quadrilateral special. The cyclic quadrilateral has opposite angles that are supplementary. This is a really cool thing that you don't get in a lot of other quadrilaterals. So that's the special thing about cyclic quadrilaterals. It's another feature of it. Yes, the definition of it, or is this just kind of location, is circumscribed by a circle, or inscribed in a circle, if you want to say it that way. And the important thing about its angles is that the opposite angles add up to 180 degrees. They're supplementary. All right, well, thanks for watching. That was the whole point of this video. Hope you liked it. Bye.